Hi everyone, today I brought a very cute question from the topic of experimental skills. These days, all entrance exams are giving importance to this topic. So, what is the question? Well, in a normal Vernier calipers, the least count is given to be 0.01 centimeter. So, this is given directly to you. When the jaws of the caliper is closed, the zero of the vernier is to the left of the zero mark of main scale. The seventh division on the vernier scale is coinciding with a division on main scale. What is the zero error? Now, to find the zero error of a vernier caliper, we have a direct approach. And the approach is, first we have to make the jaws of the vernier caliper meet or closed. Then we have to check the zero of the vernier is to the left or to the right of zero of main scale. So in this diagram I have tried to show what the question is saying. Here the red color scale is the vernier scale and the black color is the main scale. As the question said, the zero of the vernier is to the left of zero of the main scale. So whenever this happens, we say the zero error is negative. So try to remember that. So therefore, these two options are wrong. So once we know the zero error is negative, now what is the magnitude? To find the magnitude, the direct formula is, first we know it is negative. Now what is the value of the zero error? Well, very simple. You have to check which division in the vernier coincides with the main scale, but you have to count from the right side. Why we have to count from the right side? That I will explain to you later. But directly you need to remember. Again, that you have to do provided zero of the vernier is to the left of the zero of the main scale. So whenever this happens, you have to check which division is coinciding. In the question they told 7th division on vernier is coinciding with one of the division in main scale, this division, right? So we have to count the coinciding vernier division from the right. So the formula is whichever division is coinciding vernier division, counting from right side into least count. So this is a direct formula, which will be in this case how much? Minus. If you count from here, what is the division? 0, 1, 2, 3, right? So the third division is coinciding if you count from the right. So 3 into least count is given directly 0.01 centimeter. So answer is minus 0.03 centimeter, right? So this is the answer. Also try to remember that if the question said the zero of the vernier is to the right of the zero of main scale, something like this, then the formula will become for zero error plus, and this CVD you have to count from left, the normal one. So if you count from the left and if 7th is coinciding, counting from the left, then write 7 only, okay, into least count. So that you remember, okay. Now let us try to understand why we have to count from the right side if the zero of the vernier is to the left of zero of main scale. Well, to understand that, first you have to see that this is actually what is called zero error. I am representing it by x. The gap between the zero of the vernier and zero of the main scale when no reading is done. When no reading is done means what? The jaws should meet, right? Why that is error? Because it's like, suppose there is an ammeter whose readings are 0, 1, 2, 3 ampere. Okay. Now, when no current flows, your needle should stay here. Then we say there is no zero error. But sometimes what may happen due to some fault, the arrow may be here even when no current is passing. So the needle is to the left of the zero of the scale. So now let us say this gap is equivalent to minus 1 ampere. Okay. So now even when no current is passing, it is showing minus 1 ampere. So that is the error, minus 1. So when you actually pass 1 ampere, actually the needle will show 0 ampere. So whatever reading you get, you have to add 0 correction, and 0 correction is minus of 0 error. Okay. So in order to get the right answer, which was 1 ampere, whatever reading you get, you have to add to that 0 correction. And what is 0 correction? Minus of 0 error. So 0 correction is 1 ampere, right? We have to add 1 ampere to get the right answer. But 0 error is minus 1 ampere. That's why 0 correction is taken to be minus of 0 error. So that minus of minus 1 will be plus 1. Okay. So even here x would be the 0 correction and minus x would be the 0 error. So now how much is this, how to find? Well, they told it is a normal vernier caliper, right? So in normal vernier caliper, 10 vernier scale divisions will coincide with 9 main scale divisions. What that means is, if you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, these are your 9 main scale divisions, that will coincide with 0, and here will be 10. That means 1 should be this side, isn't it? Because this gap should be smaller. If you put here 1, here 2, here 3, here 4, here 5, here 6, here 7, here 8, then you will get here 9, but this should be 10. So your 1 should be closer than this one. And 2 will be here, 3 will be here, 4, 5, 6, 7, 8, 9, 10. Okay? So this is how it would be. If there was no 0 error, these two zeros will coincide. Okay. But here what happened? When you make the jaws meet, if this happens, then there is no 0 error. But here 0 of the vernier was to the left side of 0 of main scale. So this came slightly here. If this came slightly here, then this 10 will also come somewhere here. And they told 7th division is coinciding, right? So if this whole thing comes slightly here, 0 comes here, then 1 will come here, 2 will come here, 3 will come here, and that way if you go, 7 will come here. And they told 7th division coincides with one of the main scale division. So now you can easily see that that division is 6th division, isn't it? Right? So 6th division of main scale is coinciding with 7th division. So this is actually your 6th division of the main scale. So I hope all of you understood that. So from here, what will be 1 VSD? 9 by 10 MSD, and 1 main scale division is 0.1 centimeter, right? 1 centimeter in main scale is divided into 10 divisions, normal vernier caliper. So this would be 0.09 centimeter. So that would be the length of 1 vernier scale division, meaning this gap. This is your 1 vernier scale division, right? So now how to find this x? Well, look carefully from 0 of the vernier to the 7th division of vernier. So this would be how much length from here to here, from 0 to 7. That would be 7 vernier scale divisions, because this is 1 vernier scale division, 2 vernier scale division, right? And from that 0 of main scale to the 6th division, okay, of main scale would be 6 main scale divisions. So if you subtract those two, this red color length with the black color length, then obviously you will get this x, which is what we want, right? That is your 0 correction. So let's calculate this now. So x equals to 7. What is VSD? 0.09 minus 6 into 1 MSD is 0.1 centimeter, right? This is also in centimeter, this is also in centimeter. So this will be 0.63 minus 0.6, which will be 0.03 centimeter. And if you remember, that was the answer I told. But in order to get this answer, you have to count from right side. So now I hope you understood why we have to count from right side to find CVD while calculating zero error. Provided the zero of the vernier is to the left of zero of the main scale. So this is your zero correction. So zero error will be minus of zero correction, which is 0.03 centimeter. Okay.